Hassler here. We are going to work through lesson 6.8. It says, today we're going to see that some expressions with exponents and radicals are like birds of a feather. They flock together. And what that means is we're going to see many different ways to write an expression that, these ways are all equivalent to each other. What are a bunch of equivalent ways of writing a certain expression? We're going to try our best to do this without a calculator. We're going to make connections between exponent properties. So let's give this a try and see what we can do. It says evaluate each of the following. All right, remember a square root means I'm trying to find what times what gives me 16. And so the answer is 4. 4 times 4 gives me 16. Now, I'm not really sure what this 1/2 means, and so I'm going to go ahead and type this in my calculator. I'm not sure. When I type this in my calculator, remember you have to do 16, that little caret key, and then 1 divided by 2. And when you do that, you also get 4. Well, that's curious. This square root and this exponent of 1/2 give me the same result. Okay, so let's do the next one. Again, you know what? We might end up having to type these in our calculator because, I could do this one, right? Square root of 16 is 4, and then I'm squaring that, and 4 squared is 16. All right, I can do that in my calculator. That's interesting. This idea that this square root and this square undo each other, we've talked about that in an earlier lesson. But here is this 16 to the half again. So I'm going to go ahead and type this in my calculator. 16 to the half. Oh, we did that already. We got 4. And then 4 squared gives me 16. Okay. So it looks like this 1/2 and this square, again, are going to undo each other. And this last one says 16 squared and then raised to the 1/2. You know what? I'm going to use my exponent properties. When I raise a power to a power, I multiply them. 2 times half is 1. Oh, so I really have 16 to the first, which is just 16. All right, so it says, what is the relationship between square root of x and x to the half? All right, so let's take a look. I have square root of a number, and that same number to the half, and it turns out that they're the same as each other. So I think that square root of x is the same as x to the half. I know that because the square root of 16 was 4, which is the same as saying in my calculator I found 16 to the half, which was also 4. Okay. And then again, because square roots and squares undo each other, we learned that a few lessons ago, it seems reasonable then if square root and half are the same, that half and 2 would undo each other. All right, let's take a look at 3. Evaluate each of the following. All right, so I've got some exponent properties. 3 times a third is 1, so I have 8 to the first. Exponent property, multiply those exponents. A third times 3 is 1, so I have 8 to the first. All right, cube root of 8 cubed. All right, cube root of 8 means I need a number times itself 3 times to give me 8, and that number is 2. All right, so what that means is I've got 2 cubed, and 2 cubed is 8. Oh, it turns out that the cube root and the cube undo each other. We actually knew that from a previous lesson. And so same thing happens here, right? A cube root and a cube undo each other, and I'm left with 8. So it says, what is the relationship between cube root of x and x to the 1/3? And I'm going to say that cube root of x is the same as x to the 1/3. Now, this one might not be as obvious, but let's take a look. These two right here, 8 to the 1/3, ended up being the same as cube root of 8. I know that because I'm cubing those results, and when I cube those results, I'm doing the same thing to either problem. So for my final answer to be 8 in both cases, it means that 8 to the 1/3 had to be the same output as cube root of 8. Select all of the expressions that are equivalent to the given expression. So now I have 27 to the 2/3. And when I have something like a select all that apply, what I like to do is I like to work out my options and see which ones match the given option. So let's do that. All right, exponent property says that when I raise a power to a power, I multiply like bases. So 27, 2 times 1/3 is 2/3. Yeah, that works. So I'm going to circle or box that one off. When I raise a power to a power, I multiply the exponents. And so 3 times a half is 3/2. That's definitely not the same as 2/3. So B is out. Okay, so we have this cube root of 27 squared, and we just set up above that a cube root is the same as raising something to the 1/3. So I'm actually going to rewrite this. And then again, we already know that from the first problem that I have 2 times 1/3, which is 2/3. So I have 27 to the 2/3. Yeah, this one turns out to be true. And over here, when I multiply like bases, I add exponents. I have 1/3 plus 1/3. Yeah, that gives me 2/3. I would end up with 27 to the 2/3. And so, yeah, that one works out. So A, C, and D are all equivalent ways to write 27 to the 2/3. It turns out that there's many ways to write these bases with exponents. All right, finally, the last problem that we're going to talk about on this side is solving this equation. Now, we've solved equations before, but this one looks a little bit different because it has this squared in there. All right, let's just, forget about that for a second. And let's start trying to isolate this x. We're going to subtract 5 on both sides. We get 3x squared equals 33. And just like before when we solved equations, I'm going to divide by that 3. So I get x squared equals 11. But now this x is not by itself. It still has this squared. And I got to think about, how do I get rid of that square? And this is what we talked about a couple lessons ago. This is what we have here up at the top, right? That a square and a square root are going to undo each other. That's what happened here, right? A square undid a square root, which means similarly, a square root can undo a square. They are the opposites of each other. And so if I want to finish, sorry about that. If I want to finish solving this, we're back here at x squared equals 11. If I want to finish solving this, I'm going to have to take the square root. Square root of x squared, which means I have to do that to the other side. We have to maintain that balance. A square root, remember, could be the same as saying to the 1/2. And so they're going to undo each other. I'm left with x. I can actually just leave my answer as square root of 11. This is an exact answer. In calculus, we leave things as exact answers. Or I can type square root of 11 in my calculator, and 2 decimal places would be good. I get about 3.32. That seems reasonable because 11 is bigger than 9. Square root of 9 is 3. But it's smaller than 16. Square root of 16 is 4. So I'm between 3 and 4. All right. So some things that we need to get down in our notes here is that radicals can be written as a rational exponent. A radical is when we have like a square root or a cube root. So radicals can be written as a rational expression. All right, so for example, if I have square root of x, that's the same as saying x to the 1/2. If I have cube root of x, that's the same as saying x to the 1/3. And so in general, if I have the nth root of x, that n is the root that I have. It's called the index. I could write this as x to the 1/n. Whatever that root or that index is going to be in the denominator of that rational or fractional exponent. When I say rational, I mean I can write this as a fraction. I can write my exponent as a fraction. To go along with that, what if I had something like square root of x to the 5th? Well, that means that I really have x to the 5th being raised to the 1/2. And then my exponent properties apply, right? I can multiply these exponents 5 times 1/2. When you multiply fractions, you multiply straight across. 5 times 1 is 5. Technically, 5 is over 1, so 1 times 2 is 2. I really have x to the 5/2. What if we did another one? If I reversed this, let's say that I had square root of x in parentheses to the 5th. Again, I could write this as x to the 1/2 to the 5th. And again, if I'm raising a power to a power, I multiply those exponents and I still get x to the 5/2. So in general, we could say if I have the nth root of x to the m, that's the same as the nth root of x on the outside to the m. And I'm really turning that into, I'm writing 5 because 5 was the numerator that we had before. Whatever power I am raising this to, that's my top of my fractional exponent. And whatever my root or my index is, that's that denominator. So if you can see that connection quickly, great. If not, I would, use this in-between step here to see that connection between this first expression and this last expression. And then the last thing I want to comment on is that when I have something squared and the square root of something, these undo each other. So these are called inverse operations. They undo each other. Same thing if I have something cubed and the cube root, they undo each other. In fact, anything to the nth power and the nth root, they all undo each other. And so when we go to solve equations, we need opposite operations to get rid of whatever is happening. All right, so your job is to take these skills and apply them to the Check Your Understanding. And if you have questions, let me know.